Good afternoon, our esteemed members of the eVTOL press. We're holding on just for a couple minutes, see if we can't get a couple people more to join in. So we have esteemed members of Overair ready to make an announcement today that will embargo until 9 a.m. tomorrow. I'm sorry, 9 a.m. Pacific tomorrow. So that would be noon here on the East Coast. And I think that works out to about 5 o'clock your time, Charles, over on UK side. So we'll get started here in a couple minutes, and I'll turn it over to is it to Ben or to Craig to start off?
Craig will kick it off on our behalf.
All right, so I'll turn it over to Craig to get started in a minute or two so here, and then we'll have information hopefully from Craig before this is over that we'll be able to post in the handout section for you to download, and then you'll be able to create your material for tomorrow. So hang on just a minute, then we'll get started, and I'm really excited to hear what we got to offer today.
Great, thank you.
Oh, and for the folks listening, I'll actually turn on your microphones for the Q&A session so that you guys can ask your questions directly. We have no specified moderator today. And then,
so Chris, just yeah, go ahead and give me a heads up whenever you think everyone who might be attending is on, and you can go ahead and get started from there.
Okay. And then the other thing is we will take this video and we'll post it after the embargo as well. But you guys will have the links to go back and watch the raw recording prior to the embargo, so that you can utilize anything you may have missed during the session. So looks like we have 6 in attendance, which is not too bad. I know a couple of people reached out to me and said they were unable to attend at this time, but they'll take the recording and do their material. So why don't we go ahead, Craig, and get started, and I turn it over to you.
Great, thanks for the introduction. Go ahead and share my screen. So is our presentation up and running right now?
Yes, it is.
It is, Craig.
Great, thanks for confirming. First of all, we want to thank everyone who's in attendance today. We appreciate the time you're taking to join us for the webinar that was kindly hosted by VFS today. For those who aren't aware of Overair, we're a company who's developing advanced air mobility aircraft for the intention of aerial mobility, of flying passengers around. The team here has really started working on this for a few years ago, and the product, our product is named Butterfly, and it was originally announced at the Uber Elevate Summit in 2018. And since then, the team has made massive strides in growing the company and our commercialization approach for Butterfly. Since 2018, when the product was originally announced, we haven't had a significant amount of updates that have been in the public eye over those few years. And we're at a point now where we'd really like to share what we're up to and share our vision for how we plan to bring this product to market, and some of the major updates that have occurred over those few years. And to do that, we really wanted to provide a very detailed overview of the product itself and some of the underlying technology to really share some of the details that this team has put into what we think is one of the most advanced products in this space. So with that, here's the agenda for today. We do request that outside of the VFS webinar, this presentation isn't shared or distributed. It's really intended to help provide a very detailed technology overview for you. We will be sharing a press release and a press kit after the presentation, so that will have all the information have all the information in it, and a lot of the information that is in this presentation available for you to use. As you mentioned, there is an embargo until noon tomorrow Eastern time, which is 9 a.m. Pacific. So we ask that any articles that you might write aren't published until that time. Now, as far as the agenda is concerned, we'll do a brief introduction on the company, the heritage, and the history leading up to Butterfly and the design. A very detailed product overview, some details on the commercialization timeline, and then we'll provide some information on how we'll share the press release and the media kit at the end of this, and have a few minutes for Q&A. So with that, these are the folks that we have online today to help walk through the product announcement. Ben Tigner is our CEO of Overair, and on top of being the CEO, he's a very active technology contributor to the product, which I'm not sure how he's able to make so much time for being in all the very active engineering discussions. Josh Arnoff, he's our head of business development, very long experience in commercial aviation, and has helped us make huge strides towards commercialization of our vehicle. Jim Orban, who's our program manager, has come from a background of being a design lead at Sikorsky on some of the major helicopters, such as the Defiant, and then myself, who has a long-standing background in automotive and consumer electronics product development. With that, we're going to go ahead and turn it over to Ben to introduce the product.
Thanks, Craig. Look, before talking about Butterfly, we should say what the company's overall goal is. We are all about expanding people's access to opportunity by reducing the friction of travel in urban areas. If I can save people time in transit, then I've brought more opportunity within reach. And it's important that we do this in a way that is both sustainable and equitable, in a way that benefits everyone, not just a small group of folks. Next slide. All right, so many of you, I think, are somewhat familiar with the trajectory that has brought us to this point. But for those of you who aren't, we are the latest in a long line of entrepreneurial endeavors that had Abe Karam somewhere near the core of them. So Abe founded a company in the 1980s that developed ultimately what became Predator. His technology was deployed around the world and caused major disruption in how the DoD understands the idea of aircraft in military operations. Following handing off that enterprise to General Atomics, Abe founded a helicopter company, Frontier Systems, where I started working with him, and we developed some vertical lift propulsion system that was able to demonstrate higher levels of efficiency and lower levels of noise than were believed possible in rotorcraft prior to that. That enterprise was handed over to Boeing, and Abe founded his next company, which started developing, maturing the same vertical lift propulsion concept of very highly efficient, very low noise, high reliability vertical lift propulsion in the context of high-speed rotorcraft. So think aircraft that have vertical lift for hover and then tilt their propulsion forward for forward flight, primarily in the context of military applications. But in 2017, 2018, 2019, as people started realizing that electric aircraft were becoming feasible and there was a growing interest in using electric aircraft for urban air mobility and advanced air mobility, we recognized that the propulsion systems that we had been engineering, maturing for quite some time had direct applicability. And so we started working on the Butterfly product, and we decided to spin that off into a separate enterprise called Overair. And the spinoff was completed at the beginning of last year. So Overair has been operating for about 18 months as a outgrowth from Karem Aircraft, and Karem Aircraft provided to Overair all the technology, all the design data, and all of the technical expertise in terms of personnel that would be needed to commercialize Butterfly. And since then, we've been growing the team as an independent company and have been making tremendous strides. And we're here to tell you about the product that is the outcome of that. Next slide. Now, it's important to understand that the performance and safety and noise capability, low noise capability of the vehicle all benefit from having access to this tremendous wealth of technology innovation that's been cultivated over the last 20 years, starting with the A160 demonstration of very high levels of performance and low noise, but continuing through a long series of projects that some were militarily funded, some were funded by private enterprise, all seeking common goals of very high efficiency, low noise, high levels of safety, trying to extract more aircraft utility from less energy, using less energy and less power from the underlying power plant. And when we come to the context of electric powered aircraft, still energy and power are at a premium. And so if you have a propulsion system that's able to achieve high vehicle utility using very low levels of energy and power, then you have something that's very commercially advantageous. And this comes about through a large number of individual technology innovations that each build on the advantages provided by the other technology innovations that came before it. And what we've done over the last 20 years through this sequence of projects is develop a very rich tapestry of interlinked technologies having to do with the vertical lift propulsion that provide extraordinary performance and vehicle utility with very, very low noise and very, very low levels of vibration, very nice ride quality. And it's that interlinking set of technologies that really builds the magic of what is embedded in Butterfly. Next slide. So this is a quick look at the product itself. So it's a pretty fast airplane. It's 200 miles an hour. It's extraordinarily robust. And what I mean by that is able to operate in very challenging environmental conditions, gust conditions, traffic conditions. The underlying propulsion technology gives us much more capacity to generate thrust for a given amount of power. And that means we have the ability to build a lot of excess power capability, excess thrust capability into the system to make it very fault tolerant, able to operate in many, many different contingent situations, as well as in very strong weather. And in the challenging urban transport environment that we anticipate, we need a vehicle in order to develop the spotless safety record that we all will demand of it. You need to have an aircraft that is over capable of doing just the basic mission. And that is what the unique propulsion technology that we have available to us can do for us. So it's also going to be very, very quiet. We anticipate that it will be the quietest eVTOL vehicle in the field, and that is based on the fact that it has the largest rotors in the field, and we're able to spin the rotors very slowly. Not only is the amount of sound, the intensity of the sound generated by the propulsion system very low, but also the character of the sound is such that the frequency projected is at a place where the human ear is very insensitive. So it really should be an extraordinarily quiet aircraft, quieter than anything else that's out there in the industry right now. It's all battery powered, no tailpipe emissions whatsoever, no hydrocarbon fuels involved. Because it's electric powered, no turbine engine, very, very simplified drive train, it should be much, much less expensive, simpler maintenance, lower purchase cost than helicopters today. And it carries 5 passengers plus a pilot. So we are anticipating piloted operation for quite some period of time before eventually transitioning to autonomous autonomous operation, but it will be piloted operation in the near term. I'm going to turn it over now to Jim Orban to talk through a little bit more about the details of the vehicle capability and the technology. Thanks.
Great. Yeah, thanks, Ben. Yeah, as Ben alluded to, Butterfly, as we set out in 2018 to put Butterfly into existence, there were a number of capabilities and attributes that we were seeking for the vehicle. And the team has thought long and hard about how to put the best embodiment of Butterfly into existence. And it is, obvious to us that all of the R&D dividends that we put into creating, this optimal propulsion technology in the context of, medium class rotary wing vehicles for the US DoD and other customers provided this, unlocking capability of the vehicle in the form of a highly advanced propulsion system that minimizes the power consumption across all the flight regimes. So, low speed hover regimes, we are able to leverage this technology to efficiently sustain a hover and then push into the higher speed regimes also equally efficient. And it's probably worth indicating how we do that, because when you think of the context of creating an electric vehicle and switching from kerosene-based fuels to electric batteries, there's a huge premium placed on every ounce of efficiency you can get out of the aeromechanical solution. And certainly from our standpoint, we think that this technology provides, bar none, the best in class approach to electrifying vehicles that also have all the flying qualities that we're looking for. So it really starts, if you think about it in hover mode, with the choice we've made to have extremely large disk area on the aircraft. So we have 4 large rotors, as Ben mentioned. I think certainly the largest disk area across the vehicle than any of the other eVTOL concepts out there. And it provides us the minimum power consumption in the hover regime. So on the chart on the right, you can see some of the, kind of a non-dimensionalized comparison of that power profile in the low speed regime. So it's a significant reduction that gives you very much rotorcraft-like hover efficiency in terms of power consumption. We also have the ability to influence the blade pitch trajectory through a revolution with cyclic authority. So we have, not only low power, but we have extremely high control margin for us to operate this vehicle in a whole myriad of conditions. So it's a very practical vehicle that's meant for real world operations. And then as we push into the higher speed regimes to help promote the efficiency of transporting individuals from point A to point B, we've made the choice to get onto a wing, and that's where we really see a massive benefit in the lift to drag ratio. And that higher speed regime that, again, starts pushing the power consumption levels to the lowest point possible. And with that choice of large rotors, we still have an extremely large disk area in the axial flow regime. So we're able to do things like slow the rotor down and start using some of the propulsion system technologies in terms of pitch control to be able to, again, continue to push the vehicle power consumptions down, levels down to the lowest levels. So, the team's thought long and hard about this, and in the context of electrified vehicle, really proud to introduce this to the group on the phone and really put this vehicle into existence for the public. Moving one slide down, we'll expand on some of the other capabilities of the vehicle and some of the design choices we've made. So, the heart of the vehicle is really the propulsion technology. The team has been working on that for roughly 20 years through a private investment from Overair and the teams that Ben and about a dozen or other folks at Overair have been part of. It was the DoD gave us the ability to validate that, and some of their technical experts really took a critical eye to the technology, and we felt it was the right solution for Butterfly. But when we stepped back and looked at what was the environment Butterfly was going to operate in and what mission it had, safety instantly became what we think is the most important attribute for not only Butterfly success, but for the industry success as well. And the team thought about how do we implement the safest rotary wing vehicle in existence, and that led us to the configuration that is shown here. So we've been working on this for a number of years, and you'll see prominently 4 rotors, propeller systems on the vehicle, and that gives us the ability to have redundancy at the thrust level. And as Ben mentioned, the vehicle is extremely capable. We've actually designed this vehicle to sustain a safe flight and vertical landing with only 2 of the propellers operative. So in normal conditions, we have roughly 200% capacity to sustain the lift of the vehicle, and it allows us unmatched levels of performance in a normal operating regime. But that choice to have that redundancy at the propulsion level, gives us the confidence that we can implement a solution that has extremely remote probability of loss of thrust, and even after that scenario, the vehicle is still able to ensure a safe flight and vertical landing with very minimal impact on the flying qualities of the vehicle. Some of the other choices we made too to push safety, as you look, there's 4 nacelles that the way we've looked at it is those nacelles contain a lot of the critical components for the propulsion suite. So things like the batteries, the high mass items, we wanted all of those components away from the occupancy zone. So we're able to have a shell that contains the occupants that we can push that shell into the highest sort of safety zone that we can possibly envision. And we've then done all the other things we can do to try to create the safest vehicle. So we have energy attenuation through some of the crumple zone structure in the airframe, as well as some of the other features and landing gears and seat stroking to provide an extremely robust vehicle for any sort of condition. Again, looking at the capabilities of the vehicle, there's some other things we've done too to help promote some of the attributes that we're targeting. So those include things like a full authority fly-by-wire system that the teams at Karam and that we've continued over at Overair have worked through a number of years. We're also a fully composite aircraft to try to provide manufacturing throughput and minimize the weight fraction of some of the structural components on the vehicle, and as well as a number of other things that are noted here that certainly will be expanded upon on the press kit. But with that, I'll turn it over to Josh to show a little bit of the background of our thought process in creating this vehicle. There are really 4 major categories that were central to our thinking, and I'll let Josh walk through them all. Thank you.
Yeah, thanks, Jim. So I'm going to talk a little bit about the question of how does our legacy intellectual property and hardware translate to riders. It's all extremely interesting to us on this forum, but what does it mean for riders' daily routines? And Jim just spoke somewhat about it, but we boil it down to 4 rider-centric themes: safety, noise, utilization, and economics. So first is safety. In UAM, we're placing small aircraft in new, sometimes dicey environments. Butterfly's large lift, power, and controllability margins in all 3 phases of flight will ensure that safety of flight is always a given. Second is noise. If there's one thing communities value more than mobility, it might be the ability to have a conversation with someone next to you or to speak on your phone. Butterfly's large rotors that spin very slowly will make it the quietest eVTOL in production. Quietness is certainly not as important as safety on an objective measure, but it's also a necessary condition for urban operations. Third is utilization. So eVTOL uptake will depend on availability and reliability. These are, of course, not new concepts in transportation, but eVTOLs are new to the game. When the technology integrated into Butterfly was originally designed to drop Navy SEALs in hot zones around the world, robustness comes naturally. Butterfly's power efficiency will give it extra mission capability so riders can count on Overair to get them where they need to be on time. And finally, all of these factors feed into Butterfly's economics. The economic goal is to achieve very high utilization and to spread costs among as many passenger seat miles as possible so we can pass Butterfly's value on to our riders in the form of very low rates. Next slide. Here's a timeline of where we've been and where we're going. So Overair is the customer-facing brand that's harnessing 50 years of advanced rotorcraft science and making it accessible to everyday riders. Our full-scale prototype will fly next year, followed by an efficient path to FAA certification in 2025 and commercial entry into service shortly thereafter. To date, we've been tech-first, focused on executing our Butterfly program plan. Going forward, Overair will be the brand riders recognize as the most advanced eVTOL that opens the most opportunities to them, to figuratively and literally make the world a smaller, cleaner place. Ben, back to you.
Thanks, Josh. So before we get into the final specifics of logistics of the press kit and question and answer, I did want to personally mention my deep gratitude to VFS and to Mike and Jim. VFS and AHS before have been a tremendously valuable partner to all the industry and certainly to CARIM teams over the last 20 years, and we really have valued their partnership. They have been an extraordinarily important part in helping the industry and helping the government recognize the importance of continuing to advance the state of vertical lift technology, and they've played a very helpful role in ensuring that the government maintains that as a priority. And to a large extent, we at Overair owe our existence to the fact that Mike and VFS have really helped nurture this kind of technology advancement along. So I just wanted to add a very strong note of thank you to VFS. And I will turn it back over to Craig for some final words, and then we'll have a little Q&A. Thanks.
Once again, just want to thank everyone who's able to join the presentation today. For a quick overview on the next steps, we do have a press release that will be going out at 9 a.m. tomorrow. That will be going out over a wire. So we're going to go ahead and send that press release out early to the journalists that are present here today. And along with that, we're going to release a press kit that has some other information in it as well that's could be useful and would be all information that we're okay with being publicly shared in any stories or articles that you may plan on writing. As mentioned, we do request that does not go out until noon Eastern, 9 a.m. Pacific tomorrow. If you have any questions or would like to get more information, please contact Josh at this email address here for any more information. We'll be happy to respond to you quite quickly if you have any questions this afternoon. So with that, Chris, do you have any recommendations on the best way for us to distribute the materials ahead of time?
So Craig, this is Jim. I did get the press kit and the press release from Dan just a couple minutes ago.
Okay.
And I have uploaded them into the handouts section of this webinar. So if everybody wants to jump over to that tab, you'll see that there are now 2 handouts in that section, and you should be able to download them. If anybody's having any trouble, please, just message me, and I'll help you get a hold of those right directly out of the webinar. So that beats us trying to overcome our little malware issue from yesterday where we can't send out emails today. So.
Great, thanks so much for providing that quickly. So with that, we'd like to turn it over to the audience for any questions.
Let's see if we can unmute here. Charles, you're on.
Yeah, I have just a couple of questions. Firstly, could you talk a little bit about where Overair stands in terms of the investment and the capital that you have to take these next steps? And could you describe what you're going to do in terms of, increasing the size of your team to follow that timeline you showed us? And secondly, do you have any plans as a company to operate these aircraft? Quite a few of the eVTOL companies are saying they're going to be the operator as well. But are you looking to do that, or are you looking to sell these to other operating companies?
Yeah, why don't we have Josh answer the first part of that, and then maybe some combination of Josh and Craig can jump into the second topic.
Sure. So in terms of financing, our Series A financing is public, of course. To date, Hanwha Systems, a division of Hanwha Group, which is a very large Korean conglomerate, was our Series A investor and has been an awesome strategic partner. So, they obviously are a financial partner, but in addition, there are Hanwha engineers that we work with. Hanwha has very large and clear aspirations to be a global leader in urban air mobility beyond their participation with Overair. So, that we think Hanwha will continue to be an important partner, but obviously, the certification of a clean slate aircraft will require additional financing. So safe to say you can expect to see additional financial rounds, but TBD on the details. And I guess I can keep going into the second part of the question. So in terms of our business model, you know, the way I like to talk about it is these are clean sheet designs, and they're going to be unique. So by being vertically integrated, by not only building, but also maintaining and operating the aircraft, there are both technical, engineering, and financial synergies to doing that. So as market demand evolves between now and mid-decade, when urban air mobility as a space really comes to fruition, we will of course adapt to that, but we very much are interested in capturing the synergies on both the financial and engineering side that result from operating the aircraft in addition to building it.
Yeah, and to add on to Josh's comments there, that the vehicles themselves, not just us, but anyone else in this industry, the vehicles are going to be very tightly integrated with the infrastructure that they operate in through the charging methodology and how they do passenger swaps and the specific routes that they're designed to fly and those sorts of specifics. So it really makes sense to participate in some of the commercialization aspects of it as well. Between the MRO, the maintenance, the actual rider operations, the Part 135s, the resupply of replacement parts, it's a fairly comprehensive value chain. So there's certain aspects that we are looking at, and other aspects that we're considering other partnerships for handling certain parts of the ride service.
You'll recall that Bill Boeing, when he first started building his airplanes, and he was very confident in their capability, he wanted to operate them. He wanted to be the airline, and the U.S. federal government was afraid of antitrust issues there, so they actually broke it up. I don't see those antitrust issues in our industry yet, certainly. So I think that's where people's minds are, not only ours, but some of the peers that also have the same plans.
Thanks very much.
Hi, it's Graham Warwick here, Aviation Week.
Hey, Graham.
Can you just sort of walk me through the redundancy, just so I understand how this works? You have 4 rotors, at the 4 corners. So how do you have, are each of those rotors driven by redundant motors or motors with redundant wiring? And then how do you manage a rotor failure? I mean, if you lose one on the front, just can you walk me through the redundancy?
Yeah, why don't I take that? So yes, in addition to being able to operate with one complete rotor system failed, propeller system failed, we do have substantial redundancy within and across each of the nacelles. So yes, each propeller is driven by multiple different sources of torque. Multiple motors, multiple inverters, multiple batteries. There is one major battery center in each nacelle. Jim did a nice job of pointing out that the battery systems and all the heavy machinery are well separated from the occupant cabin, so that in the event of, for example, a battery failure or something like that, there's as much separation as possible. There is cross-linking between the batteries in each nacelle and the drive systems in each nacelle, so you can have a battery failure in one nacelle without losing the propulsion associated with that nacelle. All the controls are multiply redundant, so certainly there's no single point of failure anywhere that can undo the capability of the aircraft, and in most cases, dual and triple failures are things that we can tolerate and continue to have safe flight and landing. Now, you asked an important question about, suppose we anticipate that the complete loss of one propulsion system will be extraordinarily rare because of all the redundancies built into them. But in the event that one propulsion system does become inoperative, it is true that because of the balance of the aircraft, if one, say the front left one fails, then it is primarily the front right and the rear left that need to begin carrying the aircraft. And as you will remember from the various discussions of CARM, Optimum Speed Propulsion technology, we have the ability to generate substantial moments about the nacelle, about the propeller center, and so we're able to control the aircraft using the two, basically the two remaining propulsors that are still active.
Can I just ask on the technologies slide? Most of those are recognized from being familiar with OSTR, but it does say rotor speed control with collective. Are you in the hover? Are you actually operating more like a multi-rotor than a conventional four-rotor helicopter? Are you using speed rather than pitch in hover? Or?
No, so the rotors are more or less operated in each mode of flight, are effectively at a fixed RPM, but then we pick that RPM as the place that's most economically viable from a power point of view. So we're not, if you're referring to the idea of doing yaw control by differential RPM between sets of rotors, no, we're not doing that.
So what's it mean by rotor speed control with collective?
Yeah, so it's a bit of a maybe a geeky technology point. The fact that so a conventional helicopter maintains rotor RPM by you sort of think of maintaining altitude with collective and maintaining rotor speed with motor torque. Right. But optimum speed rotors historically have sort of reversed that logic. Because the rotors are reasonably lightweight, they can actually accelerate and decelerate very, very quickly. And in the development of control laws, it's turned out to be convenient and very effective to reverse that and use collective control to maintain the RPM and use torque control on the propulsion on the power plant to maintain altitude. And that has a number of sort of subtle benefits that probably better for another discussion. But okay. So it's sort of a technology point. It does provide interlocking benefits when combined with the other technology elements, but in fairly subtle ways.
Okay, good, thank you.
Hi, this is Kelsey from Avionics International. Sorry, Kelsey Reichman. I just had a question. If you could clarify the military funding you mentioned, was that directly related to this project, or?
Yeah, no. So the technology, Optimum Speed technology, was sort of originally conceived as sort of a private development, but it's gone through substantial maturation and vetting through a long series of government funding programs, to include, as far back as like 2010, there was the Joint Heavy Lift Army program that envisioned very, very large scale tilt rotors, and CARM Aircraft was a participant in that program, and we brought the idea of the optimum speed tilt rotor forward and all its different technology components. We designed versions of it appropriate for the future vertical lift, for Joint Heavy Lift program. Then we were able to get evaluations through a wide range of government experts and other technology experts from partner companies to validate that our ideas were on the right track, to give us confidence that to take the next design steps. So the government investment through a long series of programs has been used to drive the maturation of the technology in very important ways. But the underlying IP and patents came from the private investment.
Do you see any interest, or are you guys interested in participating in the Agility Prime program that the Air Force is running?
Yeah, I'm sure there will come a point in time when that will be something very beneficial for both us and the Air Force. And we've had some discussions, but we're not actively involved in it right now.
And I had a question. You mentioned that the aircraft will be piloted at first and then transition to autonomous. How do you design the aircraft now, knowing that could be the future of the aircraft?
Yeah, I mean, the fact that it's a full authority fly-by-wire system, the computer is flying the aircraft, and the pilot is telling the computer what his or her desires are in terms of the trajectory of the aircraft. You can layer an autonomy system on top of that. There will be sensors and communication that need to be added to complete the system picture. But you know, the underlying stabilization and path following of the aircraft will be there from the very beginning.
You mentioned that the first flight would be in 2022. How would you, where are you now, and how do you get there? What needs to happen before that first flight?
Jim, do you want to?
Sure. Yeah, absolutely. So, yeah, the team's been working hard, you know, since January of last year, you know, commensurate with our Series A investment, that we really hit the ground running, starting to work through a technology maturation stage. You know, so we've had the design teams really envision what is the propulsion system that we want to put into place, and have begun a detailed design effort for prototype hardware. In parallel, we've been very fortunate to find our headquarters, which we're all actually at right now, unfortunately in different rooms due to the current pandemic situation. But you know, we're all about 40 feet away from you know, a huge manufacturing area that's just on either side of this wall. So we've been able to stand up manufacturing capabilities. We have our machine shop, composite shop, avionics rooms, and we've really been working on building some of that prototype hardware. Quite a bit of it exists right now, and we're going through some of the necessary pre-flight checks to make sure that we've really focused on the core propulsion suite of technologies, and the teams are being built up and expanding to include some of the other aspects of the vehicle. So we're just leaving preliminary design and going into detailed design and releasing some of the long components to manufacturing. So yeah, huge effort to get to a flight vehicle, but you know, the teams have done this before and are really excited to see Butterfly come to existence. It's certainly a very fun phase across the company.
So is that first prototype an engineering prototype or a conforming prototype?
Yeah, at this stage, we've taken an approach, Graham, where yeah, certainly the team has decades of experience with OSTR, but looking at how this package civil vehicle that's going to be, you know, dedicated to commercial transport, you know, there's an element of discovery with the certification rules that we're going to be compliant to. So we're certainly following you know, the Part 23 approach that is you know, seems to be largely congealed across the space. So not on the phone is Peter Lyons, our head of certification. That's a huge part in what we're doing. And you know, if I step back, you know, I talked a lot about the technology, but there's a higher level strategy that we think is critically important to succeed. For us, our goal is unambiguous. It has to be a commercially viable, you know, certified vehicle. And without having a ton of inertia into a product that hasn't gone through the necessary upfront cert discovery period and embedded maybe incorrect assumptions into the design, that would be extremely damaging from a schedule and programmatic standpoint. We really wanted to have certification drive the designs. We've taken a little bit different approach than maybe others have, to take a more measured cadence into this industry. And that was really predicated based on a really deep discovery with Peter and his team to engage with the FAA. So we've been able to get into the early engagement process with the FAA's Office of Early Engagement and have natural dialogues with them, and really have started to stood up a team that is going system by system, going through the rule traces, generating our means of compliance, and that's really feeding the design teams. So that trend is alive and well, and we want that to feed into the conforming prototype. But there is a natural conflict where there are elements of technology that we know are in the vehicle that we know we need to put into existence and have that technical development in parallel. So what we try to do is implement a program structure where there's a few phases where we have dedicated breakpoints where we can put a representative system into a relevant environment, learn everything we need to, and then figure out what data artifacts or technical discoveries feed of the design. So I think we're in phase one, where it's a full-scale representative prototype that will be flying in an unmanned fashion to learn everything we can about the flight qualities of Butterfly and a number of other technical attributes. And then we'll jump into the detailed design effort to create that conforming prototype. So I hope I'm happy to jump into any of those details, but that's our general approach.
So when would you need to fly the conforming prototype to get certification by the end of 2025? Would you need to fly 23?
Yeah, we're looking at late 23 is for that, is kind of the early pre-production version of that. And what we're trying to do is minimize quite a bit of the design churn. So as we look at what the vehicle will be flying in 22, it's really focused on the propulsion suite of technologies, and then in parallel we'll be developing things like damage tolerant, compliant airframe, and working through a material allowables program. So some of those other long-lived activities that we can merge, the propulsion effort that's a little bit ahead of some of the other systems, and bring them into the design and do it in a way that we think is credible from a schedule standpoint.
Thank you.
Yeah.
This is Ken Schwartz from Vertiflight. I'm wondering, what's your approach regarding flight controls and also pilot licensing, pilot training?
Yeah, so I think that we've adopted an approach that really bites down on the notion of simplified vehicle operation, where we've sort of adopted the view that both we should have an interface that produces a smooth transition between hover control and forward flight control in a mode similar to what you see on the F-35, the unified command approach that defines how the sticks translate from hover control into forward flight control. The fly-by-wire system, by virtue of the fact that it is full authority, has the ability to implement important envelope protections that prevent the vast majority of human error type accidents that we might have. So the operator will specify the acceleration and trajectory profiles that they desire, but the flight control system will have the capability and authority to maintain the vehicle in a safe operating zone everywhere in the envelope.
And what do you consider to be the launch customer for this aircraft? I think we're going to see a sort of very crowded skies in terms of choices available to potential customers in 5 years. What do you think will be your first or your more likely launch customer? Or will it be your own initiated air services?
So it's an exciting question. I think it's largely TBD based on how things develop between now and then. So we obviously participate in conversations with all of the likely operators you'd expect. Those will evolve over time. I think most operators do realize that it makes sense to diversify not only the development and certification risk of the aircraft, but like we've talked about, different aircraft will be differently suited to different geographic regions and different environmental conditions, et cetera. So because there's no way that any single eVTOL producer can make enough aircraft to satisfy demand out of the box, I would expect to see orders being spread across multiple OEMs.
And what's your approach regarding things like IFR and icing? Is this something that you are considering from day one, or would there be further technological advancements required to achieve one IFR certification and also some kind of icing protection?
We anticipate that the vehicle will be equipped for IFR from the beginning. Flight in known icing conditions is extraordinarily challenging for all rotorcraft vehicles, and that's something that's going to have to come a little bit later.
Could I ask about the noise figures? What are you measuring? What distance are you measuring those at? We're beginning to see the various OEMs give noise figures, but they're all kind of using different reference points at the moment, so it's kind of hard to compare apples and apples. What are you using as your distance, or your altitude for cruise and your distance for hover?
Yeah, so sorry, we tried in the press, if you're referring to figures that you saw in the press release of the press kit, we tried to sort of anticipate that question. So the hover noise figure, I think, is at a 100-meter range, and the cruise figure is at a 500-meter range. And I think we tried to synchronize that with numbers that we've seen other folks around the industry use, because we wanted to be able to provide as much of a head-to-head comparison as possible.
Good. Okay. Thank you.
Where do you anticipate testing this aircraft, the prototype?
Yeah, so we've for decades we've been very comfortable operating in the Southern California desert, and so we anticipate doing that again.
Where are you actually located?
We are our central facility here is in Santa Ana, California, which is right next to Irvine. We are a very short drive from John Wayne Airport, Santa Ana John Wayne Airport.
I had kind of a two-part question about your payload and your battery technology. Could you first clarify the payload, and also, it seems like it is quite high, and also your range is longer than some of the other eVTOLs. How did you choose to go battery only instead of a hybrid option like some manufacturers are choosing? And any details that you could give on the battery technology would be helpful as well.
Yeah, so this gets to our fundamental technology advantage. The propulsion that we bring to the party here is inherently more efficient. We get more thrust for less power. That's why we're able to go battery only, not needing the hybrid solution. So we have larger rotors, larger propulsors than most other people in the industry, so we can generate the thrust needed for flight using less kilowatts and less kilowatt hours. So we said that we're 5 passengers plus a pilot. We have a separate passenger cabin from the pilot compartment for security reasons. We have separation between the passenger cabin and the cargo bay for security reasons. We're 1,100 pounds total payload capability, including cargo and passengers and occupants.
Are you guys exploring any of the other eVTOL uses besides commercial transport for people, like the business to business cargo transport?
Yeah, so I think Butterfly will actually lend itself very well to that category. You've seen a couple of the logistics orders to date, and as eVTOLs play more of a role in middle mile transportation between FedEx hub in Memphis, for example, and a smaller hub that then gets loaded onto a truck to go to someone's front door. I think it will lend itself well. I think and it gets back to the question about orders. So we've been very much in silent development, eliminating the technology risk of the development of Butterfly. And now that we're at that point, we'll be much more public facing. So we'll get a lot better sense as people realize the capabilities of the aircraft. We'll get a lot better sense of the exact applications in Butterfly's early days.
I'd like to clarify some of the images in your presentation. There seems to be, and maybe it's just perspective, two different images. One where there's more dihedral on the rear wing. At least that's the picture I was, first familiar with. But some of the more recent ones show more of a straight rear wing. Is that simply an artist thing, or are there actually been a configuration change?
Yeah, you're seeing an update in the configuration.
But
so
I think that there's not meant to be any sort of difference in dihedral.
Right. The different images in today's presentation are meant to be consistent. If there's something that's a visual effect that makes them not look consistent, then we can try to clarify that. It does look different from images of Butterfly that you've seen in the past because there has been an update.
And have you done a lot of model testing? Are you flying scale aircraft right now?
So we have done subscale aircraft flights in the past. We think that we are at a stage where that is that we need to focus on the full-size hardware. That's the best use of our resources right now.
And with the investment that you've received, is there an obligation or an expectation that you will build also in Korea or have some presence in Korea?
So Hanwha certainly has, our Korean partner certainly has very strong ambitions about their operations in Korea. We are a close collaborator with them. And I think that the Korean markets are likely to be very, very productive because I think that there is a strong public sentiment that this is something really important to help build society in future. And I think the Korean government is very, very supportive of this. So I think it's Korea is going to be a very, very fertile market. And we are very happy to support Hanwha in lots of different collaborative ways.
And one of the questions regarding capability, can this aircraft land and take off from a runway as a STOL aircraft?
It can, but I don't anticipate that that's something that we will see as tremendously valuable.
Can I just ask on the batteries, what are your performance figures? Are they based on currently available automotive grade lithium ion battery cells, or have you built in some assumption for battery improvements between now and certification?
Jim or Craig, you want to?
Sure. Yeah, we try to take a pretty pragmatic approach to the performance figures. So yeah, our modeling assumed energy density that's is existing cells we can get today. So certainly there's one of the things we touched on indirectly was that the propulsion technology we have lowers those levels to the lowest extent possible for our dynamics. And one of the huge benefits is it pushes the specific power profile down to a point where we're a lot more consistent with automotive uses that are a little bit more biased towards energy density versus power density, and gives us the advantages to use very much automotive R&D investments into that cell chemistry. So it's a huge advantage for us. But yeah, everything we've been doing in terms of performance modeling is with state-of-the-art batteries as they exist today commercially. That said, we're certainly looking at and envision a few discrete points where we snap the line and look at the cell technology in the 2023 timeframe that we will probably lock in and push that into the certified pack that goes through our initial type cert, and then several years later we will likely go through a block upgrade of the battery pack itself. to capitalize on any sort of commercial R&D investments into batteries that promote increased vehicle performance.
Thank you.
Yep.
What kind of assumptions are you making regarding annual utilization, both hours and cycles?
I'd say those figures are consistent with those you've seen publicly today.
Your published figures or what the industry is talking about?
Industry.
So 2,000 hours, years, 8,000 cycles?
Sounds familiar. 2,000 hours a year sounds familiar.
Okay.
Do we have any other questions? I don't think we've heard from Elon yet. And maybe we won't, so.
All
All right, well,
I think all my questions.
We really appreciate the opportunity to have this conversation with all of you, and thank you so much to Jim and Chris and Mike and VFS for setting this up, and appreciate the time of all the journalists who've joined us today. So thanks so much, and reach out. You have the contact information. We're happy to have direct engagement as necessary to provide material for your readers.
Thanks much, everybody.
yes.
Thank you.
Yes, thank you, Ben and team. Congratulations. Definitely looking forward to following your progress over the next couple of years. And I will share, I've already shared the press kit and press release with the team that joined in here. I will also send it to the rest of them, as well as the link to the recording, so that if people want to go back and listen to different parts of it, they can have access to that. And so, again, thank you for thinking of us and allowing us to host this for you. And I look forward to hopefully seeing some of you in person in San Jose in January.
We look forward to that too.
All right, very good.
Thanks so much, everyone.
Yep, thank you very much.
Have a great day and a good week.
Bye-bye.
And bye now.
You too.